Solar radiation is a big part of cooling load calculation. In this course, we use Excel spreadsheets to handle solar radiation calculations. Let's begin here. I'm going to show you a spreadsheet that does the basic solar radiation calculation, including solar irradiance, the direct normal solar irradiance, the diffuse solar irradiance on a horizontal surface, the direct irradiance onto a horizontal surface, and hence we can calculate the total solar irradiance onto a horizontal surface. The basic equation here is the calculation of the normal direct solar irradiation, which has three parameters, A, B, and Cn. Cn here is the clearness number. In this calculation, we assume the clearness number is 1. So we need to find A, B, and also another important parameter is the beta, which is the solar altitude angle. I'm going to begin from the final result of the calculation. But before I do that, I'm going to show you the color coding scheme of this spreadsheet. Green is for input, brown is for table lookup, and yellow is for calculation, where you have a formula in the cell. So here, the total solar irradiance onto a horizontal surface is a function of diffuse and direct irradiance onto the surface. So these two things, the direct irradiance onto a solar horizontal surface, GD itself, is a function of normal direct solar irradiance to this location. And the diffuse solar irradiance is also a function of the normal direct solar irradiance. So this is a very important thing to calculate, this calculation. And you can see this is basically the same thing as this equation. Alright, this is a function of A, B, and C, so we need to find A, B, A, B, and the beta. Cn here is 1. So A here is a interpolation, the result of interpolation of two things, these two cells. And likewise, B is also an interpolation of two other things. And C is used in the diffuse solar irradiance calculation. It's also from interpolation from these brown cells. These brown cells are table lookup. And you can see their formula. You can also see the formula up here in the formula bar. Okay. The table is here that we used for lookup. This table is in textbook. It's table 7-2. Okay, so to do the table lookup, what you need is the day of the year. Here we have over here. This is the number of the day. This is the day number of of the year, and that's a function of the date that you enter up there in a green cell. This is the date. So you need to, when you do the calculation, you need to specify the date, and so of course you need to tell the calculation, the spreadsheet, where is your location, longitude and latitude. Also, you need to tell the spreadsheet what is the standard meridian for the time zone that you're in. Of course, you need to tell the local civil time. It's the time you read from your watch. And this cell calculates the difference between the local solar time and local civil time, which is a function of the local longitude, the standard meridian for the time zone, and also the EOT, which is the equation of time. The EOT is calculated here in this cell. Of course, you can also this is a long equation that you can find in the textbook. You can also use the EOT that you find from the table lookup here. In my calculation, I chose to use the cell from above. And of course, the So here we have the input, and we went this way downward. Another centerpiece of the calculation is the beta, the solar altitude, which is the beta in this equation. The solar altitude is calculated by finding the sine of the angle first, the solar altitude angle. The sine of the solar altitude angle is this expression, which is a function of L, longitude, H, hour angle, which is the function of local solar time, and delta. Delta is the declination angle of the sun, which here I use this equation to calculate. And of course, you have another option, which is to use the value you find from the table 7-2, this lookup. Here in this calculation, in this spreadsheet, I chose to use the calculation that I've done here. And you can see this value is different than this value, but the difference is small. And this table lookup uses a different method of calculation than the method I show here, and that's why the difference. But the difference is acceptable. It's good to have both values so that you know that the difference, and then you can decide whether the difference is acceptable or not. So I have explained the calculations that can be done on this spreadsheet. I'm going to show you the names of the cells that I used for convenience, and I'm going to show you the list so that you can better understand the formulas. Okay, so that completes the explanation of this spreadsheet, and I hope everyone who watches this video should be able to recreate a Excel spreadsheet that can do the same things as this one.